Good day, everyone, and welcome to today's DevOps.com webinar. We're excited to have you here with us. Our topic today is successfully securing DevOps containerization and orchestration deployments within PKI. Our sponsor today is Sectigo. My name is Mitch Ashley, and I'll serve as your host and moderator. A few housekeeping items. The webinar is being recorded, and we will send out an email to all participants with a link to the recording and also to the slides. So that'll happen after the webinar is over. We also encourage questions. Our speakers love questions, and it makes for an interesting dialogue and even more interesting webinar. So please post your questions into the GoToWebinar control panel. Lastly, and not least, is we're giving away 3 Amazon gift cards. So please stick around until the end. And our participants today will select 3 and find out how you get those gift cards. So now let's move to our topic, PKI for DevOps orchestration. It's my great pleasure to introduce today's 2 speakers, Tim Callan, Senior Fellow at Sectigo, as well as Jason Soroko, CTO of IoT at Sectigo. By the way, they also co-host a very popular podcast called Root Causes. We'll let you know how to find that and check it out. So let's get started on our topic of PKI for DevOps orchestration. Tim, how about you take it away?
So thank you very much for having us here to Mitch today, and thank you everybody for joining us. And we are looking forward to this. And of course, as always, I do have my co-host Jason Soroko here with me. How are you doing today, Jay?
Doing great, Tim. Thanks for having me back.
So for everybody, we are trying to keep this to a nice 20 minutes. You know, we tend to get a little long-winded, plus Q&A, so that everyone can get back to their day. We do love questions, as Mitch said, and we encourage you to put your questions in chat. We are going to keep an eye on them. We might respond to some of those in real time if it's very specific to you and your situation, or you might take some of those and give them to the whole group if we think it's something everybody's going to be interested in, and that just depends what the questions are. So feel free to send those, and I'm going to try to keep an eye on them, and Mitch is going to try to keep an eye on them, and we'll make sure it gets answered. So a little bit of background. This is actually the second webinar we've done on this topic for DevOps, and this is getting a little more advanced than the first one. We're focusing on orchestration applications in particular. If you are interested in more of an overview of the topic in the field, when we're done with this one, I would recommend you go check out the other webinar. So if you go to sectigo.com/resources and just search on DevOps, it'll be in the top page of results that you get, and you can find that webinar and select it. And I've shown you what you do on this screen cap here. So I would recommend doing that if a little bit of background would be useful. But do that after this webinar, because we've got you here and you can ask your questions and stick with us now. So Jason, with that, let's take it away. So part of what we covered in the first DevOps webinar that I just described is this concept that containers need strong identity, and maybe just give us the 30 seconds on why that is.
Absolutely, Tim. So containers themselves, it's about the implemented containers. First and foremost, right, TLS as a concept, everybody knows what it's about. To go to an HTTPS website, basically there's an authenticated handshake between your web browser and your whatever web application that you happen to be talking to. For DevOps, obviously made up of all kinds of discrete pieces of logic broken up into containers. These containers are doing a lot of different kinds of things, and they quite often need to have some sort of an exchange between themselves and between other cloud applications and between APIs. Right. All of those communications need to be protected, and therefore the identity of the containers needs to be cryptographically established, and TLS, mutually authenticated sessions between these containers, are a really important concept. These things require certificates, and as you say, that means PKI.
Yeah, and they require certificates just because otherwise, one possible attack, of course, is that you get a rogue container living in your environment, and it could be stealing information or giving wrong commands or things that lead to any number of attacks and breaches. And there's really no choice but strong identity, and therefore there's really no pragmatic choice but PKI to get you there. There just isn't another way to do it. And but of course, your containers are being created or managed or controlled through your orchestration platform. And so that means that your PKI ultimately needs to be fully integrated with your orchestration platform, right, Jay?
Yeah, absolutely, Tim. The important part to note there is in most enterprise environments, you're not dealing with just a couple of containers. You're typically running with some sort of orchestration engine, and therefore the tool sets surrounding PKI and surrounding certificate management in general are typically surrounding the orchestration engine. So when we're talking about PKI, that's usually the area that we're actually talking about.
Right. And this is not a simple environment. This is a complex environment. And this is just an example. We just put together what it would look like just for Kubernetes, right? And these are all of the different ways that you need to use TLS with your Kubernetes implementation. And we're not just talking about one simple certificate type, but we're talking about a complicated environment with many use cases and many conditions where these certificates are required.
Yeah, Tim, I think that, when I'm reading the boards, looking at developer questions or operational staff questions about PKI, it's because a lot of people in this field that are perhaps not new to developing applications, but perhaps are new to security and very new to PKI. Quite
Right.
often, these people are being asked to implement things like certificate authorities and asked to make sure that the certificates are being implemented and provisioned into all these different services without really understanding what the underlying importance is of protecting things like the root certificate, for example, of your CA. There's enormous implications to this, and enormous implications to visibility to the wider risk groups within an enterprise.
Yeah, that's absolutely right. So, and I think you touched on the point we're going to make here, Jay, which is so you need to have PKI on your containers, right? So there's that means one of two things. It either means that your orchestration engine does your PKI, or it means that you have to do your PKI,
Right.
right? It's kind of a simple concept. And, it turns out that most of the time you have to do your PKI, right? So we made a list of a lot of the most popular engines here, right? And you can see some of them include a PKI option that's available to you. Most of them just do not. You just plain have to solve it yourself. And even the ones that do include a PKI option, also you can plug in your own solution through API support and do it that way instead.
If you're a developer looking at any one of these tools and you're reading through the manual about how to implement the certificate authority for one of these tools, as soon as you see an instruction that has a download for OpenSSL, right? This is a moment that should make you pause, because you're
Right.
being told to do this, and the implications of setting up a self-signed open standard CA that might be sitting on your desk, or even crazier, just somewhere randomly in some cloud structure you may have. You should really give that a pause, and I think that this is where a lot of the rest of this webinar is going to actually talk about.
Yeah, and so that's exactly right. So let's say that you're sitting in this right column, either because you have no choice or because you'd like to see if you can do, make sure that you have something that really matches your criteria for the a PKI implementation. Let's talk about what that looks like. So we kind of sometimes refer this to this as DIY PKI, right? Do it yourself PKI. And you were touching on this, like the problems, the potential problems with DIY PKI, you see here, Jay, right? First of all, just insecurity. What if how do I know that my keys are strong enough? Right? Compliance, right? Though, I mean, not only how do I know that my keys are strong enough for my own security needs, but how do I know that I'm meeting compliance requirements, either legal requirements, partner or vendor requirements, or not vendor, customer client requirements, things along those lines. Interoperability, this is an interesting one, Jay. Tell us a little about that.
Sure, Tim. So obviously, if you're up in the public cloud, there's all kinds of key management systems available to you depending on which public cloud you're dealing with. One of the problems with that is that if you choose one of them to work with, you're pretty much locked into it because the formats of how to talk to it are pretty proprietary. Additionally, quite often DevOps web applications are dealing with third-party discrete pieces of logic. In other words, your DevOps system might be talking to all kinds of third-party third-party people that you may not trust, essentially, across APIs, and therefore using a CA that is only trusted by whatever environment you have under your desk is not going to help you in an interoperability environment. If you're setting up an API that you're monetizing, that you want partners to be able to log into, having something that is trusted in a wider sense is far more advantageous. And Tim, I think it's worth even stepping back here a moment. If your first encounter with PKI and TLS certificates is the user manual of of one of these orchestration engines, I'm gonna kudos to all of you who've implemented your so-called free certificate authority. Suffice to say, Tim and I, in our podcast and in other places that we communicate, really do talk about a lot about really smart people who've been in this for years making errors that cause downtime, cause weaknesses, inherent weaknesses because of low bit rates, bad choices of cryptographic algorithms. Unless you're a 20-year grizzled veteran in this, I would say please don't do this yourself.
This is not IKEA furniture. Even IKEA furniture is hard enough. And then the last one, future proofing, right? And you kind of touched on this, which is we've seen over the years a number of examples of where the cryptographic algorithms that are considered to be best of breed when we implement a platform somewhere along the line aren't. And we have to change out our hashing algorithms or our crypto. We have to change out our rules around key lengths. And all of these things, you need to be able to make these adjustments. And, this is where set and forget is very dangerous. So, somebody sets up the PKI and nobody thinks about it, and that person goes and gets another job and nobody really knows how it all works. And, every morning we'd say a little prayer that it's not going to stop working today. Well, okay, all that's fine and well, but how are you making sure that you're staying current?
Tim, I was just talking to a customer this morning who had a CA that they had set up not that long ago that was implemented with SHA-1.
Right.
And that is a deprecated hashing algorithm. And without getting into the technicalities of it, really what's happening there is that customer is now having to completely rip out their CA for something that can be future-proof to future cryptographic algorithms. Again, if your first encounter with PKI is the user manual of your DevOps orchestration engine, don't do it yourself.
Right, and so instead you can get a purpose-built application, and that's one of the things that we believe in. And just, real quickly, I think maybe we've touched on these, but from a security perspective, right, a purpose-built application is going to handle problems like keys, algorithms, roots, make sure that those are secure and are following standards that are both smart and required, right? That's where compliance comes in. You get visibility control over the parameters of your PKI, plus you will be following standards, a basic scheme that's used by thousands of large enterprises around the globe, and those people have to be compliant too, so you're going to have a much higher degree of trust in that. We talked about interoperability. This is where a publicly trusted root comes in. So you were talking about this, Jason, but it's not just a matter of you. What if it's someone else, right? So
Right.
I could say, well, I set up my CA and blah 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 blah. Well, some stranger is setting up a CA, someone else in the organization. I don't even know who this person is, right? Now they're the CA. What if there's a problem there? And if it's all a publicly trusted root, they're just public roots. Someone else worries about those. Someone else makes sure that those are current and valid and working and universal. And then we talked about future proofing, right? Making sure that not just that your crypto is current, but everything else is done, right? If there's a 0 day, someone installs the patch. You don't need to worry about it. So all of that comes with it as well. Do you want to add anything to this, Jason?
No, you got it, Tim. Thank you.
Cool. So we also want to touch on the idea of code signing. So we talked a lot in the first webinar we did, and we also talked earlier in this webinar about the idea of all of these containers are out there in the cloud, and those containers need to basically have secure identity. But there's another problem, which is, well, what's feeding those containers to begin with, right?
Yes. Yeah, in other words, the integrity of the code. You might have done some fantastic automation coding to make sure that your DevOps implementation is immutable and it's a work of art. Is that really your code that's running?
Right.
Unless you code sign it, how do you know?
Yeah, and if it's malware, right, then you know what, you got malicious code running in your containers, right?
Yeah.
And then they're identified, right? They identify themselves. I'm protected with a cert. I'm the real deal, and everybody goes, oh, good, you're the real deal, right? But what if it was never the real deal to begin with? What if that container is full of poison?
Yeah, and for those of you who are not real experts in security, keep in mind, just because you have a TLS, a mutual authenticated session between your container and whatever your destination is, the thing is, malware can still be running on that container. In other words, just because it's somewhat isolated, somewhat segmented, is it really your code? And that's something that code signing really helps to give you that peace of mind.
Yeah, so the best practice is you should always sign the code. The deployed code should always be signed, and the orchestration engine should not allow any container to spin up except from signed code, right? And what that does is that gets around that problem. That means that a bad guy's not going to come in and swap out your file with a lookalike file that has their trapdoor built in, right? That sends your data off to Indonesia, right? That's not happening if that code is signed, because you really know it's the real code.
Yeah, or has even included a Bitcoin miner somewhere in there. Who knows?
Exactly. So how does all of this look in a real world architecture, Jay? So maybe you could just walk us through what we're looking at here.
Yeah, there's a lot on this screen, but really, if you think about it, Sectigo is a company that is, we've been running certificate authorities for 20 plus years. And because we have, one of the world's largest commercial implementations of publicly trusted certificates, we know how to protect root certificates of CAs. That's just part of our DNA, part of what we do. I would say the way that we're trying to make this interesting and easy for people in the DevOps world is two ways. And one is integrating very, very tightly with the existing DevOps orchestration engines. So all the popular ones that you see on the screen, we actually make it so that if you want to do that idea, such as code signing your applications, making sure that your container code has integrity, you might think, hey, Tim, that's a great idea, but how do I do that? Well, what you do is by implementing our product, we make it such that you never have to leave your comfortable orchestration engine that you're used to working with. We basically bake it in so it's nearly zero touch implementation of code signing. Additionally, you don't even have to utilize Sectigo as the certificate authority. you can
Right.
go ahead and have your own, or you can configure it to use us as your certificate authority. It depends on your use case, depends on your cost structure, it really depends on how mission critical your operation is and how interoperable you want to be. But what we also offer is that ability for you to say to your local risk officer, or that director of IT who's going to be on your back and say, hey, you set up a CA, but that's crazy because we need to centrally monitor that. We have auditors who are going to completely tear this company apart if they find out that there's rogue CAs sitting underneath people's desks. What we're allowing you to do is, instead of just having to go to a trusted third-party CA, we give you that ability to basically essentially monitor certificate usage from your self-signed CA, and then essentially manage those certificates and have visibility to those certificates, just like it was some kind of official PKI that was management system that's managing other private CAs within your enterprise for authentication,
Right.
for perhaps the door badge or servers, and perhaps even you might be the same people who are running SSL certificate administration and provisioning into web servers and load balancers. It's a similar concept in which we give you visibility to that. And that's
And
really what this slide is trying to say.
And this could also be a transitional strategy, right, Jason? So if I already have systems set up and I'm using a self-signed CA and I'm not comfortable with that as a long-term practice, I could bring those under management so that I know what's happening with them while I migrate them on the time frame that I'm comfortable with. But in the meantime, if I need to stand up a new service, I can go ahead and do that directly in the third-party application, right?
I'll even push that further, Tim. You're absolutely correct. But for those of you who might be skeptical and say, oh, geez, I don't want to add some proprietary provisioning technology in here, the path that we've chosen to go down is all about open standards. I mean, Docker, Kubernetes, all these other technologies are based on open standards, and so are we. In other words, we've embraced open standards such as Acme. You'll obviously see that in the web server world and in other places, but we're bringing that same technology to bear for DevOps. So therefore, regardless of how you want to swap things in the future, we're so confident of our product, Tim, in the solution that we're bringing here, that we're making it such that we're not locking you into anything. We're the opposite of the public clouds, and we're the opposite of the other CAs and certificate management companies. We really want you to have that full flexibility.
Yeah, and we actually could have added vendor lock-in as another item on our list of problems, because that is a big concern that a lot of enterprises have. And you're right, by supporting things like Acme and open standards, the vendor lock-in concern really goes away. So that's an important point, and I'm glad you brought that up. So let me plug the podcast real quick. So Jason and I do this a lot. We are publishing these at least weekly, sometimes a couple times a week. We dive deep on a lot of topics. The main thing about them is they're all about the PKI world. So we're always discussing certificates, authentication, encryption, things along those lines, policy, the law, compliance. And we always dive deep on topics similar to this. They take about 20 minutes. They're, I think, great fun to listen to. I'm biased, but that's what I think. And we'd love to have you check us out. If you go to the favorite place you listen to podcasts, iTunes, Spotify, SoundCloud, etc., and you search for Root Causes PKI, you will find it. And we'd love to have you as a listener. So with that, why don't we go to questions? Have we been getting questions, Mitch?
You bet. We have a number of questions to
cool.
toss out to you. If I can first just plug your podcast, I have listened to it. I do think you should rename yourselves to the Hobbs and Shaw podcast, referencing the Fast and Furious movie. You guys are too awesome, too funny. So
I normally say George and Gracie, but I can go with Hobbs and Shaw.
There's some really old references I could give, but I'm not going to go there. Hobbs and Shaw works really good. Okay, so let's jump to some questions. There are a lot of orchestration tools out there. Are there other DevOps integrations on the way we should be aware of?
Okay,
You
yeah,
mentioned
so we
Acme
showed
for a
this
minute.
list, and that's probably what someone's referring to, and that's a lot of the most popular, but it is a big world. So, Jason, do we have other things coming?
Yeah, in fact, it's not even just orchestration engines. It's also tools such as Chef and Puppet. You already see Ansible that was on that list, so you can see where we're going with that. So that therefore, the vaulting capabilities that might be used by something like an Ansible or others, your ability to then provision certificates from it and actually make sure that you are very well vetted in terms of your code signing and making all that really, really easy. A lot of those other types of automation systems are also on our list. I would say in terms of orchestration engines, right, Kubernetes is probably the 800-pound gorilla in the room, but I would say that any one of the orchestration engines that's popular, we do have them on our roadmap if they're not on the list already.
Yeah, and we do have integrations with these 6 tools, and the reason we started with these 6 is it's really just about, the amount of market demand we're seeing. But we do intend to continue going down this path and have very broad coverage of a large number of the tools that you need, because, the caller or the questioner is right. It is a complex environment out there. It's a complex world. There are a lot of tools. And broad support is certainly an important thing to us. It's on our roadmap. All right, what's
Good.
next?
Very good. So a number of questions might kind of roll into one here. How do we gain better
Okay.
visibility into certificate issuance and into my orchestration engine? And I would expand that, not just visibility, but you mentioned compliance also. So there's that whole reportability on compliance and, roadblocks you have to pass of certain reporting. How do you get visibility into it, and how do you have that information to help you with compliance processes?
Sure, I might even back that up just one bit, just to let people know about what that governance and compliance is. If you're a developer or an operations person, you might be just so busy in your daily work life that you might not know what the risk officer or the director of IT or the CIO in your organization actually has to work with, has to deal with from a governance standpoint. If your organization has some sort of rules that they set about themselves in terms of SLAs, either for themselves or for their customers, or if you're in some sort of a vertical that has a regulatory environment that you have to keep in check, as soon as you start dealing with PKI, typically these things are audited at some level, whether it's an internal audit or you might actually have really scary, I might say, audits that happen by the big real auditors that are out there saying, is your PKI infrastructure set up in such a way that at the very least, if you have problems with it, you know exactly where to go. If there's a certificate that needs to be revoked, do you have that ability to do that? These are all things that are far beyond just a checkbox on an auditor list. These are real things to worry about. So when you're setting up your DevOps application, you really, really need to know that list of certificates that you are issuing. What is the certificate profile? Do you have rule sets and policies around that certificate profile? These are all things you need visibility to. A lot of those things will come out of your configuration. So have you documented your configuration in such a way that somebody externally, for example, who's been brought in as an auditor can feel warm and fuzzy that you implemented RSA 2048 properly and not some lower form of RSA, for example. But when we're talking about visibility, I mean, just in terms of basic certificate management practices, you need to know what certificates you've issued. You need to know which ones you've revoked if you have that kind of a practice. How long do these things live? And unless you have at least that, if you don't have a basic inventory of the certificates that you've issued, and heck, I'll back up even further, if you don't have a really good inventory of the self-signed certificate authorities that you've set up within your organization, you will fail audits. So therefore, the question that has been asked is, how is this done? Well, it's done by basically taking inventory. With the self-signed certificate authorities themselves, you won't have enough that you couldn't do it perhaps by hand. But it is going to be a problem with the certificates themselves. You're not going to be able to just capture that within an Excel spreadsheet and hand that to your director of IT and say, here's the list. You're going to need to have real-time visibility of certificates that are being issued into these systems. And like I say, I think you have two choices. And one of them is to use an actual professionally implemented certificate authority, such as a Sectigo CA, or you can utilize the other system that we have, which essentially acts like a certificate issuance monitoring system.
Right.
So Tim, you know all about the certificate transparency logs that are used in the SSL business, in the publicly trusted business. Certificate transparency is really all about, we want to keep a one-way Merkle tree list of all the certificates that have ever been published for public trust. That's worldwide. You want to do something similar, and we're offering you that capacity to do something similar to essentially what is a CT log, but it is not necessarily for publicly trusted certificates, it's for certificates going into your DevOps environment. And that's a tool set that we offer, Tim.
Right. Cool. Do we have any other questions, Mitch?
Oh, yeah, we got plenty for you. Please
Okay.
explain the vault mechanism used in DevOps pipeline.
It's an interesting question. So you read that off of the architecture slide, I'm sure, whoever asked the question. And the vaulting tool is really there for, think about it, Chef, Puppet, Ansible, those kinds of scenarios where you want to be able to call a certificate from a safe place that perhaps has already been tokenized somewhere in your environment. That vaulting environment allows you to do that. Additionally, other types of certificate management, such as if you're using this tool in conjunction with SSL, you can actually keep a backup of your certificate. So in case something goes bad, hard drive crashes on a web server, you lose the certificate, instead of having to completely reissue, which could take time, you could call the certificate from the vaulting environment, which again, it's really all about saving you time, but keeping that certificate in a safe environment. Think of it like a certificate escrow. That's really what it is.
You mean don't put it in GitHub? Is that what you're saying?
You know what, Mitch? I'll tell you, I've even heard of people hard coding their certificate hashes directly into their Ansible scripts, and the bad guys just being like, this is too easy. You guys are just making this too easy for us.
The password's probably password 123 too.
Exactly right.
Okay. Sorry, I'm being a smart aleck here. Next question, is discovery of identifying current, this is a long question, is discovery of identifying current manually managed certificates installed in a given ecosystem in scope for your solution? If yes, does one purchase a separate discovery module, or is it part of the solution? So in other words, how do you manage on
the answer will be a lot shorter than the question. The answer is yes, it's included, and it is absolutely, yes, we can do it, and yes, it's included. So it's completely, we don't even put it on the slide because it's inherently part of what we do.
Yeah, and hugely important, right? Because that's how, if you don't know what's there until things stop working, that's a terrible outcome. And we've seen some real high visibility cases of that, in the last few years. And so discovery is real important because you find that stuff before you find out the hard way.
I'll tell you what, you make sure you understand taking inventory of your certificates before the auditor has to teach you how to do that.
Right. Or before they expire and suddenly something's not working and you don't know why and you're being fined $700 million. So yes.
That is a question that I might add to this, is how do you manage the timing and expiration of certificates so you're not getting, in the DevOps world, those calls often come to us as the developers. How do we avoid that sort of in production outages or at the minimum calls of rush to create a new certificate because something's expired?
Yeah, what's interesting about, say, the difference between public SSL certificates, which are typically, from 2 years down to 90 days typically. And that's just a set policy because, we've chosen that as the time frames. When it comes to more private trust scenarios like DevOps or perhaps IoT, I'm the CTO for IoT at Sectigo, and I can tell you, we have certificate lengths from, minutes to unlimited. And I think DevOps is somewhat similar in that way, that you really have to understand your use case properly to both make it so that it's not so long that a rogue certificate that is out in the world that's no longer being used for something that's legitimate, and if it were compromised, it would be very bad. But you also don't want to have the certificate lifetime too short so that you cause an outage for no good reason to yourself. That comes down to the art of making that decision very carefully. What I think is important here, though, is keep your certificate lengths shorter than you would expect, but absolutely make sure that you trust your certificate authority to do issuance in such a way where that's not a problem. You see, the concept of revocation is really important in public trust, but it's not really as important in private trust. Not because you never want to revoke a cert for any reason. It's simply because, think about the scenarios. If you're running a mission critical application where a container might be up for a long time, you don't want to just have a concept of revocation. You really want to just shorten the lifespan of the certificates and have renewals happen often, and time those renewals with whatever the natural rhythm of your up and down with your container happens to be.
Okay, very good. Kind of going in a little different direction here. How can we secure Kafka, the Apache Kafka, using Vault PKI? Obviously, that's a heavily integrated API-driven between connectors, stream processors, consumers, producers of content. How do you secure that kind of environment?
Sure. Well, to secure the entire environment, that could be a whole other set of webinars. But I think when Tim earlier talked about the fact that we have RESTful APIs, what he was really referring to there is if you need to do something custom and not just work with some open standard, but if you need to do something really custom, we can work with you. We've integrated into incredibly complex systems, and Kafka is just another example of that.
Very good. Let's talk a little bit about containers. And one of the things you're talking about with regards to PKI, can you use PKI for container identities to validate the identity of a container? Or is it really more talking about just using it for interconnection of different applications and services that they're talking to?
It's amazing you asked that, because I was talking to my product manager this morning about how, if there happens to be a certificate in there already used for mutual TLS authentication, for example, the only way to distinguish between the containers themselves, because quite often they're just clones of each other, is to actually look at perhaps the serial number that's sitting on that certificate. And so therefore, you can either choose to have a dedicated identity certificate, which then essentially acts as the representative identity for a certificate, or if there's already a certificate there, you could use a serial number of that. It kind of depends on what you want to do. I know that, for example, there's actually certificate standards. I wonder if DevOps will eventually evolve to the point where there's a very lightweight X509 variant that will be meant to do exactly what you just asked. That would be interesting. That's something we should keep our eyes open for.
It certainly seems to make sense. So you mentioned multi-cloud environments, and of course, certificate and CA proliferation is always a challenge with the more software and ecosystem we're working with. What are some of the unique challenges of multi-cloud and hybrid cloud applications specific to PKI, and any recommendations or best practices that you have?
For sure. The challenge is lock-in, vendor lock-in. And the challenge is also, and what I mean by vendor lock-in is if you write code that works with a proprietary key management system for a specific public cloud, that you can't transport that to the next public cloud in case you want to move wherever your loads are being executed. That's a big problem. So the other problem you're trying to solve is, if I have APIs that are sitting in my own private cloud, a public cloud, and then my partner's cloud, and I want to be able to have discrete pieces of logic within that are perhaps containerized, perhaps not, that are talking across all of those different things, it may be best to run your certificate management from a trusted third-party CA rather than just having a self-signed CA, because of the fact that probably your partners won't trust it, but they're more than likely to trust a publicly trusted CA. It's just a, I think there's a concept in PKI that a lot of people forget. It's not just about encryption. It's about inherently allowing trust to go across hostile boundaries. So think about, DevOps within consortiums, for example. How are you going to do that if one of the big consortium members who's a dominant player says, you know what, I'm going to force everybody here to run, to trust my CA? It probably isn't going to work. It's way better for the consortium, as an extreme example, to go off to a trusted third-party CA and use their rooted CA, and then you can then implement issuing CAs to each of your individual DevOps environments. It's a way better way of doing it, and it's an inherent strength of PKI. But that's why public trusted party CAs work. You might think of us again as just being an SSL company, but in reality, that public trust extends across all kinds of private trust scenarios.
Right.
Okay, good. A more general question: if I'm being asked to set up a PKI by my organization's, my dev team, maybe my manager, how do I go about creating the PKI's design, or know what requirements I should consider? Who do I talk to, either internally within the organization or externally to a supplier?
I think your job needs to really be, if whoever's asking a question like that, your job is really to understand what your requirements are, and not just your requirements from a technical standpoint, but your requirements from an outcomes standpoint. In other words, you don't have to be an expert in the difference between, ECC, 312 versus, ECC 256 versus RSA 2048, and all the other things that you just need to know when you set up a PKI. What you should do is understand your business, understand your latencies, your architecture, and what you want your outcome to be. And additionally, what are the governances that you're being held to? What standards do you want to be held to, and how future-proof do you want to be? If you take that, and what you're going to do essentially is answer the opening questionnaire to what we would give you as a trusted third-party expert in PKI. Your expertise are in your business outcomes. You bring that business outcome as well as your basic understanding of your requirements to us, and we will absolutely help you to get it right.
Very good. There's help out there. Great to hear. One of the considerations in PKI and use of certificates is always cost. How does, I know you guys aren't salespeople, but what are the things in a containerized software microservices world that you can do to help keep the cost of PKI down, to make it more cost effective and get more benefit out of PKI?
I can tell you right now, this is a big consideration. Having an economical PKI really starts with not doing it yourself. Number two, going with a cloud-based issuance platform, setting things up. If you're already doing DevOps, you're probably already in the cloud and you know what I'm talking about. It just really saves on infrastructure cost. But I would say any certificate authority and PKI that you've set up in the past 15 years is probably vastly overpriced compared to the purpose-built PKI that we now bring to the market. In other words, we're not pricing this per certificate. That's almost crazy. Think about a DevOps environment that might be consuming tens of thousands, if not millions of certificates. We're not going to charge you by the certificate. That's insane. We'll typically work with some sort of site license. We're obviously going to scale the pricing to, whatever kind of size of project you're doing. We're never going to charge you to the point where you just feel like you're being bled. That's the opposite of what we've been trying to do now with new generation of PKI. We're trying to make this so that it's a win-win. Obviously, we're trying to monetize this tool. We're trying to monetize this technology, but we want you to be successful. We're going to be charging you at a rate that makes sense to your organization.
Okay, great. I guess the message is PKIs today aren't the same as your father's PKI.
It ain't your grandfather's PKI. And I'll tell you what, a lot of this has to come down to the implementation and the standing up of the certificate authorities. Just like you guys who are listening to this who are all about automation, I applaud everybody who's getting into DevOps, because that's what you guys are doing. You guys are automating away a lot of things that human beings shouldn't have ever been doing. That's exactly what we are doing with PKI. We're automating the heck out of it to make it not just easier for you to use, but cheaper.
Great. Jason, you're in your title, you're actually CTO of IoT. And what are some of the special or unique challenges in IoT? Obviously, we're talking about much larger number of devices potentially out there in the world, but what are some of the considerations for PKI in an IoT world?
I would say the constraints. In DevOps, you're lucky because typically you're not dealing with such a constrained computing environment. Whereas you guys might be using, various flavors of Linux, etc. I might be using devices that might have no operating system at all. I might have scenarios where my network is asleep for half the time. I might have devices that have extremely fragile and extremely limited battery life, and therefore doing cryptographic functions on those kinds of environments have an incredible unique set of challenges. Just getting the certificates onto the devices themselves, whereas we can work with maybe a single open standard provisioning technology within DevOps, I need to have dozens when it comes to PKI. It's the incredible variation in the amount of computing technology that is in IoT that makes it different from everything else.
If I could just throw in my own question on this too, it sounds like you're obviously living in this world of IoT. Are you someone that people can come to with just trying to understand what the questions they should be asking themselves about how to do this, how to do PKI for IoT devices?
Mitch, I take those calls every day, and I've talked to very, very large companies, to people who really are just trying to perhaps get a startup going. I talk to everyone who's willing to pick up the phone and ask meaningful questions.
Yeah, that's super valuable. Jumping to another area, serverless applications are of great interest. Things like Lambda and AWS. Are there additional considerations for how you use PKI in containerized applications in a Lambda environment or a serverless kind of application?
Entirely, because of the fact that you're no longer dealing with an orchestration engine in the same kind of way. You're essentially using the public cloud of your choice as the orchestration engine. That would be the closest analogy I can make, which means that the whole vendor lock-in question that we've brought up a few times becomes even that much more important. So therefore, if you have a singular piece of code that is running, in a essentially where the concept of a server is now gone, and you're just addressing this thing, TLS mutual authentication does not go away. Code signing does not go away. I would say to you, the best answer I have is keep an eye on us, and on our roadmap, we will start to be integrated into these things. The reason it takes a little longer is obviously because we have to do business development work with the public clouds, but that's happening as we speak.
Makes sense. Certainly a growth area for a lot of folks. Last question. I think we have time for one more question. What are some of the most common errors or mistakes that DevOps teams, engineers make specific to PKI and containers, say Kubernetes or Docker?
I would say when it comes to something like Kubernetes, where the certificate authority is probably built in, you might be using the one that's already there. The configuration, is tough enough, but I would say quite often people don't realize that they can have a certificate authority. Even if you don't want to choose a trusted third-party CA, I would recommend setting up a singular CA that then your individual Kubernetes clusters can operate. Those are for people who are running more than one cluster, which probably is a lot of you. That's just because you want to set up that kind of trust model. Having them all broken up and having no visibility to even more just individual root CAs is going to become a nightmare. That's a bad idea. For those of you who are setting it up just with OpenSSL, for those of you, I would say you probably have even more reason to go to a trusted third-party CA and look to those services, because getting that configuration right, you don't have the benefit of Kubernetes, or you don't have the benefit of HashiCorp, Terraform, and their vaulting system to be able to help you, because those are well implemented systems. You can make terrible mistakes in them, but at least a lot of the rope to hang yourself isn't there. I would say to you, if you're opening up OpenSSL and you're running that as your CA, the rope to hang yourself is so much. It's gonna be like a bungee cord over the Grand Canyon. It's gonna be a bad day for you in the end. And so therefore, rather than finding out from your risk officer or your CIO tomorrow that was a really bad idea, bring it up with your management. Actually talk to your boss and ask the question, hey, is there a corporate policy around certificate authorities that I should be complying to? The biggest mistake is not asking that question.
Very good, very good. Well, I think that concludes our Q&A time. Thank you to both you, Tim and Jason. Those are some pretty challenging questions. So I appreciate your answers to them, and I'm sure our audience did as well. Thank you to our audience for your questions too. So let's take a moment and talk about who the winners are of our $50 Amazon gift cards. We have 3 of them. First is Richard A., then Daniel G., and lastly, Bhavya J. You'll be contacted by the DevOps.com team about how to get your cards. Congratulations to all of our winners. Just a reminder that our webinar recording and slides will be available via an email and some links in that email, as well as you can go to the DevOps.com website and look at the past webinars and see this recording. And just a reminder to do check out DevOps.com and find out what the next exciting webinar that's coming up, and maybe when Jason and Tim are back with us again. So please join me in thanking today's speakers from Sectigo, Tim Callan, who's Senior Fellow, Tim Callan, and Jason Soroko, CTO of IoT. I'm sure I'm not the first one to make that mistake, Tim. And thanks to you, our audience, for spending your valuable time with us. It's been my pleasure to host today's webinar. Have a great day and be careful out there.
Have a great day.